Okay, so today we're going to have a look at further integration by substitution. Now, the substitution that we've looked at so far has been just substitution, in fact basic substitution, when we're substituting directly in u. We're not always given the substitution being equal to u, sometimes it's equal to x. So we want to have a look at what we need to do differently. Most of it's the same, but often we will need to differentiate initially, and then we also might want to rearrange to make u the subject. So let's have a look. It's almost the same process, very similar. So we're looking at the integral from 0 to 1 of x root 1 minus x. But in this time we're using the substitution x is 1 minus u squared. Differentiate that, we get dx is minus 2u to u. Now the advantage of doing it, or the advantage of these particular types of questions, is I don't have to look for a rearrangement to get in my du, because I can just simply substitute dx for this expression straight up here without having to worry about whether I've got the right conditions or whether I have to manipulate it. We don't have to. What we do have to do is realize I need to substitute in something here, but I only have the value of x. So what I might do is say u is equal to, or we might even say u squared, and we might say u is equal to the square root of 1 minus x. So if we substitute all of that in, it's going to be the integral. Now I'm not going to do the bounds yet because we're going to change the bounds. So the integral, now we said u is equal, or x is 1 minus u squared. And u is the square root of 1 minus x, so this is just u here, and that's du. And we are actually not quite du. We're going to replace dx with minus 2u du. So we've replaced dx with this expression here, minus 2u du. So we've got the integral of minus 2 out the front of u squared 1 minus u squared du, which is minus 2, the integral of u squared minus u to the power of 4. Okay, let's have a look at my bounds now. So originally the bounds were from 0 to 1, and I want my new u values. So we've figured out that u is the square root of 1 minus x. So the square root of 1 minus 0 is 1, and the square root of 1 minus 1 is 0. So my bounds are not from 0 to 1 anymore. The bounds are actually from 1 to 0. You might think, we're not allowed to have a larger number on the top. Well, we actually are, but what we can do is we flip the integral, flip the bounds upside down, and make it a negative. So if I flip the bounds upside down, 0 to 1 of u squared minus u to the power of 4, this negative out the front dies, and we have 2 times the integral from 0 to 1 of u squared minus u to the power of 4. So this is 2 times by u cubed on 3 minus u5 on 5 from 0 to 1, which is 2 times by 1/3 minus 1/5 minus 0, which is 1/3 minus 1/5 is 2 on 15, so the answer would be 2 times 2 on 15, which is 4 on 15. Okay. Next question, we're finding the integral of x minus 2 on x plus 2 using the substitution x is u minus 2. Let's write that to the side. X is equal to u minus 2. That means dx is du. That's really easy because I can just replace dx with du. So let's plug in our x's. is going to be the integral of u minus 2 minus 2, which is u minus 4, over u plus 2, u minus 2 plus 2, which is just u, du. Again, we're replacing our dx with du. Now we're going to use that method where we separate it into two fractions. So this is u on u minus 4 on u du. Now u on u is 1 minus 4 on u du. Now the integral of 1 is u minus 4 ln of u. The integral of 1 on u is ln of u plus c. Now we know that x is u minus 2, which means we want to substitute our x's back in. So we need to know that u is equal to x plus 2. So therefore it's x plus 2 minus 4 ln of x plus 2 plus c. Now if you were to do this question without a substitution, it is possible you'd use polynomial division and you'd get to a similar step here, except you'd have an x plus 2 on the bottom. Okay, next one. We're attempting to find the integral from 1 to 5 of, how many more do I have? Two more. The integral from 1 to 5 of x on 2x minus 1 to the 3 on 2, and we're using the substitution. Let's just expand it straight up. X is equal to a half u squared plus a half. If we differentiate that, dx is equal to a half times 2 is 1, so u, or dx is du, u du. We also might rearrange our expression for u. So if we rearrange this for u, we're going to get u is equal to 2x minus 1 to the power of a half. We're square rooting that because it's u squared. We might as well now change the bounds. So the original bounds were from 1 to 5, and we're finding our new bounds. So we substitute in 1, we get 3, and if we substitute in, we substitute in 1, we get 1, and if we substitute in 5, we get 3. So those are our new bounds there for the integral from 1 to 3. Okay. So what we're going to do here is we're then just going to substitute this into our expression. So we know that x is a half u squared plus a half. Let's substitute that in. So it's the integral from 1 to 3, those are our new bounds, of a half u squared plus a half over, this is what we've figured out u was, or almost, this is u cubed, so 2x minus 1, we might write that over here, 2x minus 1 to the power of a half, all cubed is what we've got on the bottom. So really on the bottom we've got u cubed. Right, we're almost there. Here we've got a half and a half. I reckon we can factor that out and put a constant of a half out the front. So it's equal to a half times by the integral from 1 to 3 of u squared plus 1 on u cubed. Okay, so this is equal to a half times by the integral from 1 to 3 u squared on u cubed plus 1 on u cubed du, which is a half times by the integral from 1 to 3 u squared on u cubed is 1 on u, plus we might say u to the minus 3 u. So we've got a half, integrate 1 on u, we get ln of u, plus, what's that going to be? Actually, you know what I've forgotten, everyone? Sorry. We might have to delete some of these steps. I always forget that. I've forgotten my du. So we need to multiply this by u du. So we replaced our dx not with du, but u du, because we had a u du here. So Therefore, that will die, that will become a squared, which is equal to a half times by the integral of 1 to 3 of u squared on u squared plus 1 on u squared du, which is a half times by the integral from 1 to 3 of 1 plus u to the minus 2 du, which is a half times by the integral of 1 is u. The integral of u to the minus 2 is minus u to the minus 1 from 1 to 3. If you plug that all into your calculator, you get 4/3. Alright, sorry about that mistake, but that is the correct answer there. Okay, I think this is the last one for this video. We're looking at the integral of 1 over root 5 minus 4x minus x squared, using the substitution x is u minus 2. First up, we might say, okay, x is equal to u minus 2, which means that dx is equal to du. And we might look at that denominator at the moment. Let's just look at substituting in u into that denominator without the square root. Minus 4u plus 8 minus u squared plus 4u minus 4, which is 9 minus u squared. So we can say this is the integral of 1 over the square root of 9 minus u squared, and we replace our dx with du from up here. Now that's just in the form sine inverse, so again we need to take out our factors. So we might take out 1/3, the integral of 1 over, this is the square root of 1 minus u squared on 9. Again, look back at the previous video if you've forgotten how to do that. We take out a factor of 9 here, divide this by 9, the square root of 9 is 3, so we put a 1/3 here. So this is equal to 1/3. Again, we would like to say, well, first up, that f of x is u, not f of x, f of u is equal to u on 3. That's because its squared is u squared on 9, which is this down here, and f dash of u is 1 on 3. So in an ideal world, we want a 1 on 3 up here, but to do that I need to times this by 3. So that 1/3 and that 3 will die, and we're left with sine inverse of f of x, which is u on 3 plus c. However, u is, we don't know that yet, so if x is u minus 2, that means u is x plus 2. So therefore it's sine inverse of x plus 2 on 3 plus c. Alright, thanks for watching.